Welcome back, Math 136 students, to the Module 07B Problem of the Week. In this problem, we have the half-life of carbon-14 is 5,600 years. If a piece of charcoal made from wood of a tree shows only 72% of the carbon-14 expected in living matter, when did the tree die? So what we need to know first is the function we need to use for exponential decay when it's continuous decay, and that would be a of t is equal to a sub 0 times e, which is the irrational number e, to the kt power. We're going to start by using the fact that the half-life is 5,600 years. Half-life means half of the original amount remains. So half of the original amount would be 1/2 times a sub 0. And this is equal to a sub 0 times e to the kt power. But we know t because it takes 5,600 years for half of this substance to remain. Now we need to solve this for k. We're going to start by dividing both sides by a sub 0, which leaves us with 1/2 is equal to e to the k times 5,600. Now we can do one of two things here. We can either convert this over to logarithmic form, or we can evaluate by taking the log of both sides, the natural log of both sides. So either one would work. If we convert it over to log form, what we have is the natural log, which is log base e, of 1/2 is equal to 5,600 times k. We now solve for k by dividing by 5,600, so we know k is equal to the natural log of 1/2 divided by 5,600. This is the exact value for k, and I strongly urge you to avoid your natural instinct, which is to evaluate this using your calculator and getting a decimal, because that is a rounded number, a rounded answer, which means it's not necessarily 100% accurate. We really want to use the exact value for k in our next step. Now we need to look at our situation where we have 72% of carbon-14 remaining in this piece of charcoal. If we have 72% of the carbon-14 remaining from the original initial amount, that means we have 0.72 times a sub 0. And this is equal to a sub 0 times e to the kt power. Now because it's the same substance, carbon-14, we know what k is because it's the natural log of 1/2 divided by 5,600. We can also simplify both sides by dividing by a sub 0. So I'm going to do both things at the same time. So on the left side we have 0.72 equals on the right side e to the natural log of 1/2 divided by 5,600 times t, and all of that is part of your exponent. So at this stage I have two steps I could do. I can either evaluate both sides using the natural log, or I can convert it over to log form. I'm going to choose to convert it over to log form, which means I'm going to have log base e, which is the natural log, of 0.72 is equal to the exponent, which is the natural log of 1/2 divided by 5,600 times t. Now I'm trying to solve for t, and I know our instinct is to divide by the coefficient, which in this case is the natural log of 1/2 over 5,600. Instead, I'm going to multiply both sides by the reciprocal, which the reciprocal is 5,600 divided by the natural log of 1/2. This cancels out the coefficient on the right side. I now need to multiply the left side by the same thing. And so as a result, what I get is that t is equal to exactly 5,600 times the natural log of 0.72 divided by the natural log of 1/2. So this is the exact solution. Now in your calculator, you can type in 5,600 times natural log, that'll open a parenthesis, type in 0.72, close the parenthesis, divided by natural log, that'll again open a parenthesis, type in 1/2 or 0.5, close parenthesis, and then hit enter. As a result, what you get is that the approximation for years is about 2,654 years. All right, guys, I hope that helped. Good luck.